Hello everyone, welcome to a tutorial on ice software. This is an introductory tutorial on the ice software. We will be discussing what ice software is, how it works, what are the different algorithms which you use, and what are the simulator used in this software. So let me say about it. So what does ice do? Ice do is what ice does is circuit optimization. So a lot of people will be having difficulty in understanding what circuit optimization is. So circuit optimization is the optimization of structure or various parameters such that the satisfy our conditions and uses less resource or something like that. So I will explain it with help of a DC circuit. Okay, this is a circuit. So in this case you can see F2 is the logic. We can implement in these two methods. Method B uses less resources and method A uses more resources and it's more complex. So we can say method B is more optimized circuit structurally than method A. So similarly, in case of analog circuits, we can also do this structural modeling but only for certain circuits or certain parts of circuits like that of fermentation. We'll be discussing that in our later tutorials. So other is the parameter optimization. So what is parameter optimization means we'll be tuning to find the value of these passive elements. For example, I have this output voltage as 5 volt average. So to get 5 volt average, you need to understand what is the value of RE, what is the value of R2, what is the value of RC2, what is the value of RC1, and all these things. So earlier we would be using a mathematical model. So what mathematical model will be meaning is we will be having like resistance R1 is equal to an expression like R2 by R3 plus R4 by R3, some kind of expression. From that we will be deriving the resistance which is required for getting like 5 volt or 3 volt or something like that. In this simulator we won't be using that because we will be using a mathematical model free modeling. So what it's not a complex term, trust me. It's just we don't have to make equations. It will be found out by the software itself. So let's see what the simulator requires the user to provide. So there are three things. First, the user has to provide the diagram of the circuit. The second thing, the user has to specify what are the parameters he or she wishes to tune, which includes like resistance values or the value of inductors or capacitors. These are the things which is meant by parameters. So user has to specify which resistance to tune, which capacitors to tune, which inductance to tune. That's what the user has to specify. The next thing is the user has to specify what are the targets he wishes to achieve. These include like the average voltage across output. Like suppose I need 5 volt average across the output. In such cases, we will be specifying the software. This is the output we need. We need to tune the resistance value so that I could get the desired value. So this is how the basic optimization section works. There is also a topology section in the simulator which we will be covering in later courses. So I'll be explaining an algorithm which we will be using, that is LSGA2. It's a multi-objective optimization algorithm. So the reason we chooses LSGA2 is because it could be handling a lot of tuning parameters, that means R, L, C or kind of values. It could also specify a number of objectives like average value, RMS value and all this stuff. So it's really important because a good algorithm could only be actually optimizing. So this LSGA has an ability to deal with a lot of targets and parameters. So we'll be using that. We'll be also experimenting with different algorithms in the future. So let's talk about the simulator we use. The simulator we use in this software is Python PowerPoint. It's an open source software. The reason we choose is because it's written in Python. Then it can be running low-end computers fastly. And unlike conventional other open source simulators, it does not take data as netlist, but as a CSV format. So it could actually help the user in draw. That's what I mean by here, diagrammatic view of circuit. So instead of giving some table format, we could actually give as a CSV format. I'll show it to you what I mean by this netlist and CSV format. So this is what netlist format is. See the R1. This is the resistance here, R1. Its value is 1K. It is represented in like this tabular format. R1, it is connected between node 2 and it is connected between node 3 and its value is 1K. This kind of representation is netlist representation. So in case of very large circuits, it is very difficult for the user to actually visualize as well as write in this format. So we decided to move to this simulator, which could actually help us in drawing in CSV format. So I'll show you what it is done by CSV format. So this is a representation. So it's easy. It's simple. See, this is an inverter. So we have a voltage source, a switch, a diode. We got actually 4 switches and 4 diodes and a load. This is similarly represented with the help of this CSV format. I'll show you. Okay. See, this is the voltage source. This 11A voltage source. This is connected to an ammeter, and we have a voltmeter in parallel, which could measure the voltage. Similarly, when we are connected, we have a switch. We are connecting a diode parallel with the switch, and we are connecting it to some place. Jump 1 is actually connection to the other part of the circuit, which we will be explaining in the later session. And this switch 2 is the switch which is connected in the bottom leg of the inverter. This is a single phase inverter. So it's actually simple. A voltage source and a meter. Then we have a voltage source in parallel. Then we have a switch. Then we have a diode. Then we have a switch here. Then we have a diode here. It's actually like drawing. So the reason we are using this method is because we have to run this in cloud, so we need the program to be as fast as possible, so to get faster results. So having GUI actually reduces, no, it not reduces, it increases the time required to get the desired results. So we thought it would be better, so if we run it. So this is how CSV format is. So what have we learned so far? We learned what ICE does, what circuit optimization is, what is the algorithm which is currently used for ICE, and what are the simulators we have used. So these are the things we have learned today. I hope you enjoy the classes. See you next time.